Hello everyone. Good morning all. I welcome you all to.
Morning.
Uh, so should we wait for few? Yeah, we will wait for 1 or 2 minutes, and then we will start. Okay.
Okay, sir.
So my screen is visible now.
Yes.
Yes.
Yes, sir.
Yeah. So you all gone through all the lectures of week 8?
Yes, sir.
Yeah.
And what about the graded assignment? Have you completed that or what?
I've done the activity questions, not the graded assignment.
Okay.
Same, sir. Activity questions only.
So I tried some and I was not able to solve some of them also.
Okay. Okay. So when is the graded assignment deadline for week 8?
I think
Must be
Sunday.
Sunday.
21st, I guess.
Okay. Okay. So yeah, you have time. And for quiz 2, the syllabus would be up to week 8, no? For quiz 2.
Yes, sir.
Okay, so this is your chapter, yeah. Okay, let's start discussing the lectures. Okay. So yeah, first question. What would be the pattern? What we should keep the pattern? Like we will. Yeah, I'll ask the questions, and yeah, any one of you can answer that. And yeah, if anyone has any problem in that question, at that time only, they can stop me, and we will discuss that question. Okay.
Okay, sir.
Yeah. So yeah, let's start with the first question. Feasible direction is the property of objective function, which is given to minimize constraint function, both fx and gx, and none of the fx and gx. Okay. So what you consider as the correct answer?
Constraint function.
Yeah, exactly. Constraint function only gives you the direction of which is feasible or not. A direction can be called as a decent direction at a point x. The corresponding objective function value increases, decreases.
Decreases in that
Decreases.
direction.
Yeah, exactly. The function value should decrease in that. Then already it will be called as descent action. Otherwise, it will call descent direction. If function value will increase in that action. Okay. Yeah. So yeah. Third question is, which of the following condition is needed to be satisfied to decide whether the point is indeed optimal in case of constraint type? Okay. So what are the conditions which is the function should satisfy so that we can say that it is indeed optimal or not?
Both A and B.
Both A and B. Yeah. The point should satisfy the equality constraint. Yeah, no descent action should be a period. Yeah, that's true. So yeah, the fourth question is, a vector D is a descent action for the function. Okay, so yeah, which one you think is the correct answer?
Force.
Less than 0.
Yeah, exactly. So I would again tell you, if anyone has any doubt at any particular question, they can stop me at that point. Okay, then we will discuss in details. Otherwise, we will just move forward like that.
Sir, in this question, what is D transpose?
That is direction vector. Okay.
Direction vector. Okay. So like we have been given 2 points, like 1 and 3 and 2 and 5. So direction vector will be, if we do the subtraction, then we'll get the direction vector.
Exactly. Yeah, let's go to the activity question 8.2. Okay. So yeah, if any value x star which satisfies constraint equation gx less than 0, then any descent direction of fx star will also be a feasible direction. So let's say for this question. Yeah, hello.
It's true, sir.
Yeah, I think many so many discussion happens on this question, so that's why I'm stopping here. Yeah, anyone has any doubt, they can ask. Yeah, hello. See the question. Yeah, yeah, please speak.
So there is no doubt in this.
Okay. Then I think yeah. Right, yeah. So the second question says that to minimize the objective function fx under the equality constraint gx less than equal to 0, which of the following is necessary condition for optimality of some point x star? Okay. So yeah, what is the necessary condition?
Anti-parallel.
Yeah, I think yeah, all these things are already mentioned in the directly from the sir's
Yes, sir.
notebook only. Okay, so yeah, to minimize the objective function fx under the inequality constraint gx less than equal to 0, the necessary condition for optimality is del of fx star equals minus lambda times del of gx star, where lambda should be a positive scalar, should be a negative scalar. Yeah, what you guys say?
So
Positive
positive
scalar.
Exactly. And in case of equality constraint, what would be the?
arbitrary scalar, sir.
Yeah, it can be positive or negative both.
Yes, sir.
Yeah.
Sir, in case of equality constraint, can you please explain the geometry behind it? I mean, sir explained, but I am still having some confusion there.
Okay, regarding that geometry, no? Okay, that means.
So, is it possible to give one line reasoning for all the questions that you do? Just one line reasoning
About this question or which question?
about all the questions that you'll do from now onwards.
Okay,
Just
okay.
one line reasoning, nothing more.
Okay.
Thank you.
Okay, let me say. So yeah, so what the condition was here? So my screen is this blank screen is visible, no?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay, so what it was saying is if this one is, let's say, your del of x star, okay. So the Dixon derivative, which was around d transpose del of fx star, it will be opposite to this one.
Yes, sir. Anything behind it? Yes, sir.
Okay. So that is the case. Okay. And again, if your so all the thing depends on the del of gx star. Okay. If del of gx star is in this direction, okay, del of g of x star, okay, then your d transpose this one d transpose del of g of x star will be in this direction. That will be also in this direction. Are
Same
you?
direction.
Yeah.
Yes.
And in case of anti-parallel, what we are saying that your d transpose del you can change the color. Okay. In case of anti-parallel, and then your d transpose del of g of x star will be in this direction. The thing is the value of this is 0. Okay, so we are the only direction which remains is around this one. Okay, this line only.
Along this line, yes, sir. Yes,
Yeah.
sir.
So yeah, and along this line, all the value will be same. So that's why this condition satisfies. It doesn't matter whether both of them are parallel or anti-parallel. In both cases, you will get the same answer. Is that fine to you?
In case of along the line, the direction of d transpose del g star will be along the line, no sir?
And D transpose del object star, this value becomes zero, no? Along this line.
Along this line, yes. So if I
So
mean,
along this line, the value of del of your f of star value will be same. It won't decrease or neither it will increase.
yes, that is what I'm okay.
Yeah. So that is the case. Okay.
Okay, sir. Okay.
Here D transpose will be a column vector.
Yeah, D transpose like that only. It's since C, it's a dot product. No. So what we do is like sometimes we just do as we write it as as whatever you are saying. Yeah, that's if D is in your column vector. Okay. If it is your column vector, then let's cross one. Yeah, that's why D is column vector. So then D transpose will become your row vector. Okay, something like that. It depends. Actually, you can do the mathematical part. Okay,
I want to confirm that D transpose and del F both will be the column vectors, and these are just dot products.
Yeah, exactly. See,
Okay.
the Daxon vector, it is called as usually we call as a you can you would have read about in mathematics about the Daxon derivative. So that is nothing but del f del f dot v. Okay, so it is what it means is like Daxon derivative of f along v Daxon tells, and what it tells is it is the rate at which this f will change while input moves with velocity vector v. Okay, like this Daxon derivative is defined. Okay, that's it's a mathematical term that is which is used here. Your d transpose del of just we did this transpose just to so that we can multiply properly. Okay, it depends completely on the matrix like in which the d is given. So if you are able to multiply it directly, then it's okay. Otherwise, here we have used d transpose, so it means Okay, let's go. So I think now it is visible now.
Yes.
So activity question. Let's go to 8.3. So to minimize the objective function effects under the equality constraint gx equal to 0, which of the following is necessary condition for optimality of some point x star? So we know that to check the optimality condition, there are two. The function should satisfy that constraint equation, and these two functions should be parallel or anti-parallel, both. So they were discussing this option is either A and C. Actually, it should be written something like either A or C. Then this option would be correct. But the main sense, the question is framed in such a manner that some language barrier is there. Here we are seeing. But I think all of you know the answer. It should be either parallel or anti-parallel. In both cases, this is the criteria only. Okay. I think anyone has any doubt? Anyone?
No, sir.
Okay, so I also saw just now today only, like someone was discussing about this on Discord. So I thought language problem is there. Either we are using and with the word either, so it's not a correct. So second question says that to minimize the objective function effects under the equality constraint gx equal to 0, the necessary condition for optimality is del f of x star minus lambda of del gx star with the Lagrange's multiplier lambda. Just like in the last question only we discussed. It can be any arbitrary scalar. Okay. In general, is it possible to solve a system of equations that satisfy the Lagrange's equation? What would be your answer? Anyone?
No.
Yeah. Why no? Anyone just say? Because we can get many different kind of complicated equation, and it's not always possible to solve them analytically. Okay, so that's why this gradient descent projected gradient descent algorithm came into the picture. It is like that. Okay, so yeah, that's is there. Nothing fancy is there. Okay. So yeah, fourth question is in projected gradient descent method, we first take the gradient descent step and then project it onto the feasible set. Yeah, that is true. That is what we do in the projected gradient descent. And in normally gradient descent, what we do, like we just do the iteration like that. So yeah, this one is also true. Okay. So fifth question says, which of the following optimization method is useful in constraint optimization problem? Okay. So yeah, gradient descent is for unconstrained optimization problem. Okay. Method of Lagrange's multiplier. Yeah, this is one which we read on the like first 3 lectures that we can use for constraint optimization problem. But yeah, the condition here is, yeah, the equation should not be that much complicated. Okay, like that. Okay, then we have projected gradient descent method, which is also an iterative algorithm which we can use for up to some certain extent. Yeah, if the equation is complicated, still it will work. Okay, like that. So yeah, these two are correct answer here. Okay, now let's move to the activity question 8.4. Okay. So yeah, this question says, yeah, given S is the convex set in R square, R2 R square.
Number of things that
Here.
related are going to get illustrated via the case.
Are you saying something here or hello? So yeah, given S is a convex set in R square space, subspace, and yeah, x1, x2, x3 belongs to S. Yeah, the point x3 equal to lambda x1 plus 1 minus lambda x2. Which of the following is always true about the range of lambda? So I think many of
0
you
to 1.
It can be any range because there's an x3 also. It's not just x1 and x2.
okay, yeah, exactly. I'll show it. See, we will go. This question is intentionally given to just confuse you. Okay, so we will follow the sentence. Okay, the question is saying, yeah, given S is a convex set in R square. Okay, my line is visible or not? Whatever I am drawing, is it visible?
No, sir.
No, sir.
Now it is visible, the red line.
Yes, sir.
Yes.
Okay. So just to go, we will go through each and every word. Okay, so first word is given S is a convex set in R square subspace, and x1, x2, x3 belongs to S. Okay, just note this one. Okay, x1, x2, x3 belongs to S. So this is our sample space. Okay, let's say we put here as x1. Okay, or here as x2. Okay, x2, and here as x3. Okay, so we have all the 3 points. Whatever is written in the first sentence, we did that. Okay, this one is x1, this is x2, this is x3. Okay, like that we wrote here. So yeah, up to this point, everyone is with me. Like I'm just simply just represented this point as graphically. Yeah, someone can say if anyone is not agree with me or something like that.
Sir, you are putting all the 3 points kind of linearly, collinearly.
Yeah,
So
we can put anywhere you want to put here. I can put here also. Okay, no, it doesn't matter. Okay, see, it will be 0 to 1 only if I will put x3 in between these 2 points. Okay, if I'll put any at any other place, okay, then our lambda value will be more than 1. If we will place here, the lambda value will be negative, something like that. Okay, so that's why intentionally I just, yeah, I don't want to put the x3 in between these two lines. So that's okay. In that case only we will able to see that, yeah, lambda value is more than 1. Okay, so that's why I'm just drawing it like this. Okay, so let's say x1 is around 1 unit. Okay, x2 is around 2 unit, and x3 is around 3 unit. Okay, so this condition we are here we are able to satisfy this condition. X1, x2, x3 all belongs to S, and now we'll see that whether this x3 we have the value of x3 now. Just use this equation. Okay, x3 is around 3, and lambda times x1 is 1, lambda into 1, just keep lambda 1 minus lambda, x2 value is 2. Okay, so 3 equals lambda plus 2 minus 2 lambda. Okay, so what we will get here is lambda equals to 2 minus 3 minus 1. Okay, are you ready? Yeah, are all of you agree with me?
Yes, sir.
Yeah, so we are able to see here that even all these 3 points are in this subspace, still this value of lambda can be uh, more than 1 and also less than 0, something like that. Okay, so we can't say anything about this lambda. The question, the sentence which we are mentioning every time, which is written in the, I think in notebook, you will see that. Can someone say what is the written as a sentence about that when lambda is 0, when lambda will be between 0 to 1?
x1, x2 will belongs to S, and this lambda x1 plus 1 minus lambda x2, the whole equation or the result of this equation will also belong to S.
Yeah, so it is a definition of convex set, that a set is a convex if and only if 2 points we take, and yeah, if it that 2 points if we take, and that is that the third point which satisfies this equation, no, then that set will be a convex set. Here in the question it is already saying, yeah, these all these 3 points are in this convex set only.
Okay.
Question has already mentioned, yeah, S is a convex set and all these 3 points lies inside that convex set.
So
Okay.
it is like,
Yeah,
it is like, I mean, whenever I am putting lambda equal to -1, in this case, the diagram which you have drawn, so x3 is kind of beyond x2. So we are not only in between x1 and x2, we are going beyond x2. So that's why lambda can be anything.
yeah, so here that equation was particularly for the case where x1, x2 and x3 belongs in between these x1 and x2. Okay,
Yes.
so that was a case where x1 and x2 was there, and yeah, x3 was in between x1 and x2. Okay,
X1 and x2, yes.
yeah, so that was the definition, like if we have 2 point x1, x2 and x3 in such a manner that all the x3 value lies on this line. Okay, and yeah, all these 3 are in this same set. Okay, so that was the case. So yeah, a set is convex or not. Yeah, so yeah, I think yeah, can move further. So yeah, this question was given intentionally just to check that. Okay, that's it. Yeah, so the second question says, given x1, x2 belongs to S, if x3 equals lambda x1 plus 1 minus lambda x2 is also member of S. where lambda belongs to 0, 1, then the set is a convex set. Yeah, this is the exact definition. Okay, so the previous question was just to confuse that. Just here, this is the condition when if all these 3 points will satisfy this equation, then we will call the set as a convex set. Okay, still, if anyone has confusion in these two questions, they can ask. Yeah, hello. Okay, let's move to the third question. Okay, so given if x1 x2 belongs to S, then x1 plus x2 by 2 belongs to S. If this is the condition, then the set is, I just tell whether the set will be convex.
Convex.
Yeah, so I would say there are some cases where it won't satisfy the equation. The thing, because why? Because this is the definition of actually midpoint convex set. Okay, and this is the definition of midpoint convex. Okay, but there can be a case where midpoint convex set is not a convex set. Okay, particularly for irrational numbers. Yeah, I think yeah, this one was the issue. Okay. So yeah, let's move to the next question. Yeah, so fourth question says a set is informed using two closed interval -3, 1 and 1, 3. Okay, as shown in the picture. Is this a convex set?
No, sir.
Yeah, always think like if someone says about that how convex set will look graphically. So for that we can say yeah, a set is convex if any 2 points we take in the that set, and if we draw that line in between those 2 points, that also lies in that convex set. No, then it will be a convex set. Okay, so suppose in this case, if you see here we are if we are taking a 1 point here, 1 point here, so if we'll draw a line between these 2 points, this line completely doesn't lie in this set, so obviously this won't be a convex set. And yeah, here it is convex set. Like that only, here we are seeing that yeah, point lies from here to here and few points are from here to here. Okay, so it's a discontinuous set. So yeah. Yeah, listen.
Sir, in the previous question, you said that x1 plus x2 by x1 plus x2 by 2, if that is the that belongs to convex set, then it doesn't always mean that all of them belongs to convex set. Yes, sir, and I also think that is true, and but the answer gives convex set only. So
Yeah, answer is giving convex set, but the thing is this is the definition of a midpoint convex. Okay, midpoint convexity. But the issue is, I would tell you, midpoint convex is not always a convex set. Particularly in case of irrational number, it doesn't satisfy this condition. Okay, all the convex sets are midpoint convex set. Okay, but all the midpoint convex sets are not convex set.
yes, sir. I mean, like if the diagram you just draw, if the midpoint lies in the convex set, but let's say the 1/3 of that point is not lying in the convex set, then it is not a convex set.
Uh, just say what you are saying. Okay, we'll draw that.
Yes, you can draw a bun like that non-convex set. You can draw a non-convex set.
Okay.
Yes, sir.
Yeah.
Okay. So if I am saying now here just a little bit down.
Yeah.
Can you point the cursor just yes, this here. If the midpoint is lying here.
Okay, midpoint is lying here. Yeah.
Yes. And so that means and the x1 is lying a bit left of it, and the x3 is lying a bit right of it.
Okay. This one is your x1, this one is your x3. Okay.
I mean, x3 is what I'm trying to say is x2 is also lying in the other part, but the x1 x2 is coming inside the convex set, but x1 plus x2 by 3 is not coming inside the convex set. That can be case, no?
Yeah, so in that case, it is not satisfying this equation, no? So what you want to prove? Just to tell me that. I'll directly answer the whether it is.
There should be what I am trying to say is there should be an option that it can be either a convex set or a non-convex.
Yeah, that if that would be option, that option only is correct here. Okay. If
So
there,
then, so shouldn't the answer be none of these?
yeah, that would be a better answer. I'm also saying that only.
Okay.
See, yeah, the thing is here, in this case, what is happening here? The question is saying that x1, x2 both belongs to S. Okay. And then all the question should be something like that. What the definition says of midpoint convex. If x1 and x2 both belongs to sample spaces in such a manner that all the point, if we take any point that is which satisfies x1 plus x2 by 2, it also belongs to that sample space as, then we call it as then we call it as a midpoint convex. Okay. And all the midpoint convex sets are convex sets, but particularly in case of irrational numbers, it doesn't satisfy. So, but if you see the vice versa, that all the convex sets are midpoint convex sets. So if a set is a convex set, something like this, if x1 is here, x2 is here, so all the x3 value which satisfies this equation will lie in this one. It is a midpoint convex set is nothing but just a particular case of lambda equal to 0.5, nothing more than that. Okay. So I will summarize this one by saying this, that this question's answer would be none of this. Okay. See, x1, x2 both belongs to S. And then if this question is saying that x1 plus x2 by 2 also belongs to X, then the set S is a convex set, not always. Particularly if the question is mentioning about it for rational number, okay, then it's correct. Otherwise, yeah, for irrational number, it won't be in that convex set. But yeah, one question here you can say, yeah, all the convex set are midpoint convex. Yeah, that's all the convex sets points satisfy the midpoint convexity. Since we haven't read about anything about midpoint convexity, so we won't discuss that topic in details. Okay, but yeah, I just told that definitely nothing extra is there. Okay. So yeah, which of the following are true statements about a convex set S? Okay, if x1, x2 belongs to S, then lambda x1 plus 1 minus lambda x2 belongs to S, where lambda belongs to 0, 1. Okay. So yeah, just tell whether
All of these.
yeah,
All of them are correct.
yeah. First and second statement is nothing but just improvisation of this one. Just we separated the lambda value here. Okay, yeah. The line segment joining any 2 points of the set S also belong to the S. Okay, so yeah, all of them are correct. So yeah, sixth question is saying which of the following can be called convex set. Okay, so this is a hyperplane equation, W transpose X equals to B. Okay, Euclidean ball with center XC and radius R, such that X belongs to X minus XC transpose into X minus C belong less than equal to R square, and half space. So you have idea about what we call as half space, what is we call as hyperplane? Any idea?
No, sir.
Okay, I'll show you that. Particularly, there is a support vector machine. Okay, so there is a machine learning algorithm, support vector machine. Okay, you will read obviously in MLT, MLP. So what happens is we just there are 2 points, 2 different points. Just see here all something like this is a line. Okay, this is a line, and here can you visualize that as a 3D shape? Okay, it's okay. Yeah, just see in 2D only, because I think I won't be able to draw in 3D. So yeah, that's why I'm saying. Let's note that. So what is there is, yeah, see this line is dividing the whole XY space into two part. Okay, one is below this line, second is below above this line. Okay, so this line is normally your see what happens in the 3D geometry. This here in 2D we are seeing it is a line. Okay, but in 3D it will be a plane. That plane is called a hyperplane, which is just dividing the whole subspace into parts. Okay, so this part is also called as a half space, and this one is also called a half space. Okay, this one is a negative half space, and this one is a positive half space. So yeah, like that. So for this equation, for this line, this equation is W transpose X equals V. Okay, it is nothing but just think it as a Y equals MX plus C, something like that. Okay, this line equation. Why we have written here in this shape W transpose X equal to V? Because in this like that we use in ML algorithm. This W is your weight vector. Okay, this X is your feature matrix, something like that. Okay, and this V is your target vector. Target vector. Okay, so for your knowledge, for now, you can think that this one is this line which is separating this, which is just dividing your whole subspace into parts. That is called as a hyper. In 3D space, we call it as a hyperplane. Okay, for that, this see, it is a line. So its equation will be something like that. This only, no, Y equal to MX plus C, something like in this shape only. No? So that is this one. Okay. And if any value that is lesser than this one, then our W transpose X is less than equal to 2V, then this is called as a half space, lower half space. Okay, this one we call as a lower half space. Also, we call it as a lower half space. Okay, so since it's less than equal to B, actually it can be of two types. In some cases, we can write it just less than equal to B. Then it's like open half space. Okay, but if we consider this half space plus this hyperplane line, hyperplane also, then it will be a closed one, and then the equation will W transpose X less than equal to B. Okay, like that. Yeah. So I think and this term will be widely used in hyperplane, not half space, but hyperplane here. So it is nothing but just divide the whole area into two parts. Okay, let's move to the. Okay, so which of the following shape is a convex set? Okay, what about this one shape?
Yes.
It is.
Yes.
Yeah, because all the line which we will draw, any 2 points we will take in this set, and we will draw a line between them that will lie in this set only. So this one is your convex set. But what about this one?
No.
No.
Yeah, obviously, if we will draw one line in between these 2 points, it won't lie in this convex set. Okay, so that is also correct. Actually, this is So what about the second one? This one, this is the third one.
Yes.
That is also correct. And what about this fourth one?
No.
And about
No,
the
sir.
about the
Yes.
fifth one?
Yes.
Yes, yes.
Exactly. About the sixth one?
No.
No.
Is anyone having any doubts in all of them? In any of them? I think just in all this type of figure, just try to just try to draw a line at a particular critical points. Okay, and see whether it is lying in this shape or not. So here this is the critical line. Here this one is a critical line. Okay, like that. Yeah, so I think we are done with the activity question 8.4. Let's move to the activity question 8.5. Okay. Yeah, so a convex hull is defined as a convex combination of vectors x1, x2 such that xn such as it's also directly comes from the definition only. Okay. So which one would be correct? Just say
D.
D.
Fourth one.
Exactly. This one is correct because in the third and fourth only a difference is this lambda I less than equal to 0. Obviously, if it it will be all the lambda will be less than equal to 0, then it won't result a lambda equal to 1. Okay. So yeah. Fourth one is the correct one. And yeah, a convex hull is always a convex set. Is this statement true? Just see.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So I would say to visualize this convex hull, think something like a rubber. Okay. What it is doing, you have so many pencils, so you are just trying to put a rubber on all those pencils, so that it gets combined. Something like that. It works like that only. Like we have so many different convex sets, and we are just trying to see the at intersection, like that minimum possible point, that club of minimum possible. All the common points, something like that. Okay. Yeah. So yeah, third question says, which of the following holds true for a convex hull? Okay. Yeah, it's just an intersection of all the convex sets.
Yes, sir. A.
Yeah. Which of the following operations will result in a convex set always? Okay. Which operation will result in a convex set always? So yeah, intersection, we know that, yeah, intersection is a convex set and that is always a convex set. Okay. So yeah, this one is correct. And union of two convex set, we can see here, particularly that, yeah, in the left, IQ 8.4 was there, that question was there. So in that case, when we had something like this, so yeah, if we are taking union of these 2 points, it's not a convex set. Okay. So yeah, this one is your correct answer, and multiplication of each element of a convex set with a fixed scalar. So what do you say about this one?
It is a
Sir,
convex set.
no, sir, but in this actually I have this doubt. If you multiply with a fixed scalar, it may go out of that range, no? So whether it will still, remain part of that convex set.
You're multiplying each element, so will the set not become bigger then? It will all increase.
How it set, how we draw this set? Okay, the point is 3, 4. If it is lying in this one, okay, so I understand what you're thinking. This set is something like this step. So if we'll multiply this one for this, then it will go outside. It is like not like that. It is like, yeah, if we are multiplying these two, then the set is just a set. This line is just a representation. Okay, this shape, this is just a representation. So obviously that set will be also bigger.
Okay. So we can also look at it like this. So the example of that parabola. So the parabola will only change its, it will become broader or narrower, but sort of, the point will remain within that. We can I think visualize like that.
Yes, you can think like that. Okay. So
Okay.
Okay, let's move to equation.
Excuse me, sir.
Yeah, please tell.
Sir, I wasn't able to derive the proof of convex hull is a convex set.
Convex?
Convex hull is a convex set. Sir gave an exercise, this as an exercise.
Okay.
A convex hull is a convex set.
Yeah, so that you can put on a discourse, or there only I can, because I also need to solve each and every step. Okay.
Okay, sir.
Okay. Yeah, so yeah, the assignment will be okay. So yeah, this question is saying something. This question is talking about epigraph of a function f r did such that r is defined as. What is the its exact definition? Which one is the correct?
Fourth.
D.
Fourth.
D.
Yeah. Okay. So let's move to the second question. Which of the following shaded graph is an epigraph? So according to the definition, what is the correct shape of epigraph?
First one.
First
Third
one.
one.
First and third.
First and third one. This one. Yeah. See, why not this fourth one?
So this is not a convex set.
But not even a single word is there in the question which is saying about that it is a convex or not. It is simply asking which of the following shaded graph is an epigraph. Okay. Actually, it's a question mistake. The question was supposed to mention here that it should be a convex, yeah, it is asking about convex sets, but it is not mentioned. So yeah, in that case, yeah, that option is also correct representation of epigraph. Yeah, this one is not a correct representation of epigraph, and yeah, but and this one is also not a correct representation of epigraph. But this is a correct representation of epigraph. Epigraph is like that, but yeah, this one is not a convex set. That is true. So yeah, if
Sir,
you
can you please explain why B is not an epigraph in convex set?
this one in the epigraph definition only we are seeing that all the value of the z is greater than fx. Okay, so in this case you are seeing that here your fx value is this one. Okay, so the epigraph value is more than this one. So if it would be drawn in something in this manner, okay, if we have shape like this and we have drawn your epigraph something like this upward like this, okay, it's I've just other lines are inclined, but yeah, think it like as a straight line, something like this. Okay, if that would be the shape, then yeah, this would be also a case of epigraph. Did you got my point?
Oh, sir, here I missed. I'm not very clear.
Okay, I'll just explain it again. So the definition of epigraph, just okay, I'm not able to make it. See, the definition of epigraph says you have to draw z's in such a manner that it is always greater than fx. Okay, so here in this case your function is something like this. Say your function is representing something like this. So this one is your function. Okay, more the points above this fx value. Okay, so that will be a representation of your epigraph. Think it like yeah, any if you are any shape given to you, just draw all the lines upward in upward. Okay, just shade the regions. Okay, upward shaded regions will be called as your epigraph of that function, something like that. Just you can think in yeah, easy terms.
So then that means if an epigraph is a convex set, then only it's a convex function, right?
Yeah.
So then if the upward is the upward part of any graph is epigraph, then option B should also be right, no?
Where it is upward part, just see, this is your function, this red one, the darker red one, this is your function, so it is shaded below this one, no?
Okay, so the area covered is below that, below the graph. We are talking about the area, no?
Yeah, yeah, you can say about the area, or yeah, that is also you can say.
In the first one, the area is open above it.
Yeah, we don't have any issue about that open area or closed area. We are saying that, see, this z should be always greater than fx. Okay, so here this line is your fx. Okay, so you have the function is given to you in such a manner that if you draw that function, you will get this kind of shape. Okay, this kind of shape. Okay,
so sir, in that one in B, so had they shaded the upper portion, then it would have been epigraph.
Exactly.
Okay.
We can think about if we select any particular x, then our shaded area should be above the fx on that particular x.
Yeah, exactly.
And that that above should belong to that function. The above part should belong to that function. Like in case of B, it is not belonging. It is kind of outside the function, right, sir? Yes, in this one it is going outside the function.
So it will not be a convex set, that's it then. It will still be an epigraph, but it won't be convex.
Exactly. So if it would be yeah, whatever you guys said, that's correct. This is a epigraph, but this is not a convex set. Exactly.
This second graph,
this one.
Yeah, why is this not a convex function?
When I said that this is not a convex function, this is a
Okay.
convex function. Yeah.
It's not an epigraph, right? Okay.
Yeah, it's not an epigraph. Okay, so yeah, the epigraph of a function is a convex set. When
Sure, but option D is marked as wrong in the portal. So is
yeah,
it a
yeah,
mistake?
yeah, it's a mistake only here that the question is hasn't mentioned anything about this convex.
Okay.
It's just like that. That's why the third option will be correct. Okay, we can do two things here. First, we can mention the that if convex term in the sentence, then yeah, the this so yeah, A and C are correct. And if we don't mention that, then yeah, we have to select this option as also correct. Okay, this C option will be also correct here. So
Okay,
yeah,
got it.
yeah. So a function cannot be a convex function if its domain is not a convex set. Is this statement true?
Yes.
Yeah, sir clearly mentioned in this lecture that if domain is not convex set, then the function won't be a convex function. Okay, so
Yes,
the
sir.
graph of a function Rd, which is function is in Rd domain and yeah belongs to R, is a convex set when f is a convex function, f is a concave function cannot be determined. So yeah, it clearly see in this graph that yeah, your f is a convex function if epigraph of a function is a convex set. Okay. So which
what is a concave function? What is the definition of it?
Concave is just like that will give you the maximum point actually. Just this shape. Here, this one is a convex shape, no?
Okay.
This one is a convex shape. Then if you just plot it is something like this. Okay. So this one is your concave shape. Okay. Here you will get when we do the same thing, only just sign change will be happen. Then you will get the maximum point. Here you are getting minimum point.
Graphically, it's clear, but what is the mathematical definition for this
About what you about
concave, yeah.
A function something in such a manner that all the points just nearest to this are here you are saying that this is greater than this one, and there you will see that all the points are the values are lesser than this one. Okay.
Okay. So all four definitions of the convex functions can be, with these changes, be applied to the concave function also.
Yeah. You can just by changing the signs. Okay.
Okay.
Okay. Which of the following is true about a convex function? There must be only one local minima. There must be multiple local minima. Local minima is also global minima. Local minima and global minima may not be same. So which of the following is true? Always true.
1 and 3.
Which one?
1 and 3.
Yeah, there must be only one local minima, and local minima is also global minima.
So
Two,
the
right?
answer 2 is correct, but I don't know why it is 2. I'm not able to understand.
Right.
Which one?
Yes, sir. So second option is correct in the portal.
Yeah, I would show you why it is correct. I was also thinking, as you said, that with why it is written as. Okay, I'll show you just by saying, see, particulate, see this graph. Okay, how many minima points are there? Local minima is there.
Infinite.
It's for like the semi-definite case, right?
Yes. So how many minima points are there? There
So
is
multiple, yeah.
Multiple in minima point is there, local minima, and but the one thing is that all of them are equal. Okay, so it may be a case where we have multiple local minima, but the case in that case what will happen is the local minima will be a global minima. Okay, so it can happen that we may have more than one local minima, but yeah, all of them them will be equal. Did you got my point?
Yes, sir, got it.
Yes, sir.
Yeah, so yeah, this one and this one is correct.
Just to B and C, no? This B
Yeah.
and C.
Yeah. A function is said to be a convex function if for all x1, x2 belongs to IDs and lambda belongs to 0, 1. Okay. So which one you think? It is also directly from the definitions.
Second.
Second option, sir.
Yes. So is anyone of you having any confusion related to this one?
No, sir.
Yeah, okay, I move further. Because the last step we are discussing about the linear approximation of a convex function at any point in its domain always lower bounds the value of the function at that point. Is this a true statement?
Yes, sir.
Yeah, exactly. It's true. And if anyone wants in kind of Jack's pictorial representation, then I can show you, or else, yeah.
Yes, sir. Please show it. Please show the pictorial.
I will draw the figure, the same figure which sir has drawn. Okay, so here was your x star. So what this was saying is, if its approximation was there, no? Here we are taking any point as a y point. Okay, this one is x, and this one was your y. So here, if it is x, then this one is your fx, and this one is your fy. Okay. So what this is saying, that linear approximation of this point, which is this one, it will be just I didn't draw it properly. Like here is your x, so x, there is this one is your y. Okay, so what is happening here is we are saying this fy and this here you will get your linear approximation, which is nothing but just fx plus, just take it as a tan theta. Okay, tan theta is this one is nothing but your tan theta, which is just we call it the gradient. Okay, del of fx star. How we define the gradient? Can anyone tell?
The partial derivatives of the variable. Vector of partial derivatives of the variable.
Physical representation. Just tell about that.
So
Yeah.
Is it slope?
slope.
Oh, yeah.
Yes, it is a slope. It is just a slope, nothing else. Okay, so that is nothing but equals to tan theta. Am I right?
Yes.
Okay.
Right.
Yes, sir.
Nothing but this value. Just take it as a k, and this one is your y minus x. Okay, this one is y minus x. Are you agree with me? It is nothing but k upon y minus x. So the k
Yes,
value will be y minus x into del of fx star. Okay, so this approximation is what? Fx, this one is fx plus this k. K is nothing but y minus x star plus this one. Now you will see that like from where this one term came, y minus x into del of x star. Okay, so limit approximation is nothing but actually, yeah. Sorry for my bad handwriting. Y minus x, this one into del of x star. Okay, just so I think, yeah, now you would be able to see like from where this term came. Okay, this one, yeah, and it will be always less than this your fy value. Okay, and like that only on the previous term also. Yeah, previous questions also, like something we will get the similar figure. If anyone want to, we can show that. Yeah, we will move further. Okay, so yeah, Third, this one question directly, this question's answer also comes from the definition only. We have seen that. Okay, so let's move to activity point 7. Okay. Set of all global minima of a convex function forms a convex set. Is this a true statement?
Yeah.
Yeah, set of all
Yes,
global.
sir.
Yeah. A convex function f such that R2R is to have a global minima at point x star. If gradient of del of x star is 0, there is no direction to move from x star where the function value strictly decreases. There is no direction to move from x star where the function value strictly increases. So tell me, which of the
First
following?
and second, sir.
First and second.
Exactly. Like in the first, first activity question 8.1 also we saw this similar kind of question. Yeah, just framed in different manner, nothing else, nothing different here. So yeah, we can move to chapter practice assignment 8. Yeah, this question. Okay, I think so many times. So many.
Sir, can you please mute everyone? I think somebody is unmuted and there is some background noise.
Okay, let me check that. Actually, what happens is when I open this tab, okay, Ranjit, can you mute yourself? Okay, I mute him. Are you still getting any noise?
No, sir, we can proceed.
Okay, now it's okay, sir. Yeah.
Yeah, okay.
Thank you, sir.
Yeah, it's okay. Okay, so yeah, now given if x1, x2, comma x1 plus x2 belongs to x, okay, belongs to s, then 3 by 4 x1 plus 1 by 4 x2 belongs to s. Is this a true statement? Again, here,
Yes, sir.
In this question, the question was whoever created the question, he was trying to say that this function is a midpoint convex function. So for that definition is like something like if for all x1 and x2, if x1 plus x2 belongs to s, then sorry, just reset my term. Hello. Yeah, hello.
Yes, sir.
Yes.
Sorry, delivery boy was there. Okay. Yeah. So my screen is visible now.
Yes, sir.
Yeah. So this question, the question should be framed in such a manner that if for all x1, x2, such that x1 plus x2 belongs to s, then in that case, yeah, this statement would be true. Okay, because it is nothing but just if okay, let me see. Here is your x1, here is your x2, so it is just exactly a midpoint of x1 plus x2, and this one is nothing but just the midpoint of your these 2 points. Okay, if you solve, you will see that. Okay, but the thing is, question is not clearly saying this one, whatever the, so that's why this question has become just kind of ambiguous. The question is not directly saying that if For all x, if I can introduce the two terms here, like for all x1 x2 belongs to x1 x2 comma x1 plus x2, or we can frame it in such a manner that if for all x1 comma x2 such that x1 plus x2 belongs to S, then whether this will belong to S or not, something like that. In that case, we can say, yeah, is this a true statement? So did you got my point? Or so that's why, since question hasn't mentioned clearly that point, that word, so yeah, that's why we are seeing this. Yeah, many discussion on this question on the discourse. Okay, because how many of you are in the support of this? Like whether its answer will be yes or whether its answer will be no. Like how many of you are saying that its answer will be yes?
So I think it should be yes.
So it should be yes.
It should be yes, sir.
Okay. Just by seeing this question also, or you if after some changes? Hello.
So I think
This question only.
Sir, we
went-
already said no that if it belongs to, if it's a convex this thing and it belongs to that, then only the set only increases. So if you multiply by the multiply with some scalars.
Yeah, we told that if you multiply with some square, then it will be still will be a convex set only. Okay, that's the correct one. But the thing is, yeah, hello, and some other yeah. Any other argument? Hello.
Hello, sir. At least I can think only of that much.
Yeah. That some other people is saying, but his voice is very slow. Actually, someone is saying something. I felt it's okay. Yeah.
x1, x2 and x1 plus x2 divided by 2 is an element of S. So it's a clearly a line segment and this is the midpoint.
Okay, just say.
And
Yeah.
so in this case, if you take x1 plus x2 divided by 2, then it's also an element of S. It is the midpoint of first and third.
Okay, let me just write some different figure. Here,
Of course, sir, you can have a funny shape in which the midpoint will also lie in S, but then some middle portion may not lie. That is also quite possible actually.
exactly. That is what I wanted to draw. Here is your x1. Here is your x1 plus x2. This one is your x1 plus x2 by 2. Okay. So what I'm saying is our shape is in such a manner that just think it like this. Okay. Or if you want, I can again do this. Okay. So yeah. Okay.
Yeah, sir. If we have this funny type of this thing and it is not a convex set and function, then yes, then we can say it will be new.
Yeah. So that what the question should be framed. That is what I'm saying. Yeah. So it is not always. It won't be always correct. If the question is written in such a manner, if the we will correct it. If we'll write the questions in such a manner that if x1 x2 such that for all x1 plus x2 belongs to S. If for all one term, if we will write here, then yeah, it is a direct definition of midpoint convexity, midpoint convex set, and then yeah, in that case, yeah, this will be a true. Okay, because the question itself mentioned for all x1 plus x2 by 2. So question is saying if we will take any 2 points and the midpoint will lie in this set. Okay. Did you got my point?
Yes.
Yeah. Let's move to the next question. Which of the following is a convex set? Which one you think is a convex set?
See.
So can you solve this question? Like how we will go about it?
Yeah, I can solve it. And yeah, I think just by saying my writing, I'm also thinking that I should show all these questions directly from PDF. Here you can see the yeah, after double representation, yeah, you can check this one. But yeah, I will just share that directly that PDF only. Just open that PDF. Okay. Is this visible to you all?
Yes.
Yeah. So in the second question, just see here, what we are doing is we are just simply differentiating, we are taking the second order differentiation. Okay, there was a definition in that one, no? Like the last definition, which was saying that if double differentiation is greater than 0, did you definition 4?
Yes, sir. Yes, sir.
Yeah.
Yeah,
Yes,
and
sir.
properties of convex
Yeah.
function.
Yeah, F is convex if and only if there is two variable x and y, then yeah, it should be a positive semi-definite matrix, or otherwise it should the second order differentiation should be greater than 0. Okay, greater than equal to 0 actually. Non-negative, it should be non-negative, because in case of semi-definite also it will be your convex function. Okay, so in the first question, yeah, when we are differentiating with the do square fx upon do x square, we are getting value as 0. Okay, so yeah, so it is a convex function. For the second question, we are seeing that when we are doing double differentiation, we are seeing a square e to e raised to ax, that is also greater than equals to 0, because for any value of x, doesn't matter whether it's a positive one or negative one, we will get as a it as more than 0. Okay, and since it is the a square, then also here also, like whether it doesn't matter. Yeah.
Sir, just one small question. Sir, if you see the first choice, like ax plus b, like it's a straight line. Yeah? So actually, if you see it's an infinite line, and you will not be able to find a minima unless you specify some type of range. Yeah. So if you see that way, whether it is correct to call it a convex function, because it has neither local minima nor local minima, yes, if you have some range. Otherwise, it has no minima actually.
Yeah, it is a question of something like this one, no?
Yes, sir.
Yeah, it will continuously decrease. So whatever the point you are saying, that is correct. And I would say, yeah, we should mention some limit here, like x belongs to something like that, 0, infinity, something like that. Yeah.
So is that why there are multiple definitions?
Yeah, I would also say that's correct. But I think, yeah, I also need to see this one, because from the graph we can say that whatever C is saying, that's the correct one. If there is some line, okay, although it is satisfying our definition, but yeah, but if it is just a straight line, then yeah, where we will say that it will be a convex function, something like that, where we will see that minimum value, something like that. So what you are saying, just say.
But what I was telling you, it will have actually, if you see, it has no global minima. So like you always talk about a global minima. So
Yeah,
only in some set it will have. That is the only thing that I want to say.
Yeah, your point I got. That's why I said that we should attach some terms here, like x belongs to this point, this comma, this, something like that. Okay.
But if you take the epigraph definition, then it's a convex function, right?
Yes, in that case we can say it like that. I also need to check. Okay, I'll also confirm this one.
Okay, sir.
Yeah, I agree with both the statement, because yeah, it is satisfying your equations part. Okay, but yeah, we are seeing that if you won't mention any any belongs to the domain of x, then it will be like something like that, infinite graph, no? So that is whatever you are saying, that everything is correct. If we will just mention that domain of this x value, then yeah, that will be correct. But yeah. Okay, so second option is saying, yeah, we are saying that yeah, it's fx equal to e raised ax over r, where a belongs to r. Okay, so yeah, we are saying that yeah, a square will be always positive, e to the power e raised ax will be also positive. So yeah, we are saying that yeah, double difference will be always greater than equal to 0. Okay, so yeah, in that case, yeah, this one is also a non-negative value. And
So finding if a function is convex or not, we just need to check its whether its double derivative is positive or negative.
yeah, two thing. For different cases, you can use the different definitions actually. Yeah, in this case, you are seeing that yeah, all of are like only one variable is there, and we can easily we can easily do the double differentiation. Okay, and we can clearly see that after double differentiation, whether it will be greater than 0 or less than 0. Okay, in all the questions. See, in the fourth one also, like we see that 6x. Okay, x value can be positive or negative both. So yeah, here you are saying that yeah, x cube can be can be positive. X cube double differentiation of x cube can be positive or negative both. So we can't say. So it's obviously not your convex function. Okay.
So how do we know which definition to use? Because if we use the minima definition, then like number 1 will not be correct. So how do we know which definition to use for which question?
See, exactly. In the first one, I'm also saying, yeah, minima definition. Obviously, that is a graphical representation. Ultimately, every all the any definition you follow, at the end, all will say the same answer. Okay, if you are able to, it is like you have different tools to solve that problem. Whatever the tool you are using, just use it correctly. Okay. So here in the first question, as I am also saying, yeah, since we haven't mentioned anything like the range domain of x, so I'm also a bit unsure. Okay, so just keep it as a in the doubt section only.
Okay, sir.
Yeah. Okay. Otherwise, in all the cases, if you will draw the graph of, just draw the graph of each and every questions. Okay, you will see that yeah, all the shape of all the graph will be something like this only. X square shape is this. Okay, and the same case of e to power a is x. Okay, something like this we see graph of no 2.7x, something like that. Okay, so like that only. Always you will see in that shape only. But in the x cube, the graph will be something like this. So here we don't have any minima. There should be a global minima. Okay, the graph should be for any question. You just, if you are able to visualize the graph and you are able to visualize that graph, then you can directly say that whether it's a convex function or not.
Okay, sir.
Okay. Yeah. So yeah, let's move to the third question. What is the value of a? The function f pertains to r fx xy ax4 plus 8y is a convex function. Here, this one question. Then again, you have to plot the you have to draw the Hessian matrix. Okay, and you have to check just create this Hessian matrix and just check whether it's all eigenvalues are positive or not, or also you can check that whether it's D's determinant should be greater than 0 and a value should be greater than 0. Okay, so this is your Hessian matrix, and we are able to see that 12a x square, since the determinant will be it should be greater than equal to 0 because it's a positive similar. Okay, so we can check here the first value is 12a square. Okay, so to be it would be a convex function if this value is should be greater than 0. 12ax square should be greater than 0. Since 12 is already positive, x square is also positive, so a should be greater than 0. Okay, one condition we got from here. Okay, second condition we also we should check this one, like a determinant equals 0. Okay, so 12a square into 0, it will be 0, 0, 0. So your determinant will be always 0. So the only one condition we see as a greater than 0. So yeah, this one will be the correct option.
Sir, for more than two variable function, how we will form this matrix?
Again, you can form this if you have variable, let's say x comma y comma z, then you can form like this, no? Do f do square do q by not the, then it won't be a Hessian matrix. It will be something like the do cube do y cube or do x cube, then do square y, something like this shape. Do x do y do z by do x do y, something this if you have seen, no? Like it will be a 3 by 3 matrix. Okay, it will be a 3 by 3. First we differentiated 3 times with z, and then we differentiated 3 times with x, then we differentiated x y z twice with y, once with z, something like that. Did you got my point?
Yes.
Yeah, so it is like f x x x f x y z yeah, f x y y, then f x y z, something like that.
So does it have to be differentiated 3 times for finding out for a third order polynomial? I mean,
we see, no, like we had to be honest, I have also haven't seen any questions on that one, like this shape, like this 3 by 3 matrix, but I think yeah, like that only, like we will create that matrix around, yeah, after the differentiation only. Yeah, yeah, we will do the 3 times differentiation thrice.
okay, okay, sir.
So we have to check our term was like f is a convex only if it is a twice differentiable. Okay, and yeah, f is a convex if it is a twice differentiable, and yeah, h is a positive semi-definite matrix. So we have to check this, whether this matrix is a positive semi-definite matrix or not. Okay, but yeah, I also haven't solved any questions on, yeah, which had 3 variables. Okay, so yeah, like yeah, I also have solved up to like, yeah, z equal to x plus y, something with that one. So yeah, we are just doing this, keeping the function do x, yeah, do x do y, something like that over there. Okay. F function x transpose ax is a convex function if, which one is correct? Actually, yeah, that's exactly the definition of A is positive semi-definite matrix, and yeah, A is a positive matrix. Since if it is a positive definite matrix, then it's we can directly say that yeah, it will be a semi-definite matrix also. Okay. So because as from the definition, you know that yeah, if it's a positive definite, then yeah, your eigenvalue should be greater than 0 if it's a positive definite, and if it's a semi-definite, then eigenvalue is greater than equal to 0. So yeah, all Hessian matrix is if it is a positive definite, then yeah, always it will be a semi-definite also. Like last time a big discussion happened on this point. Like if a matrix is positive definite, then whether it will be positive semi-definite or not. And also, if you check on the Google, so yeah, many different sites and different things are written. Like at many places, I also saw like many books, even not on the books, yeah, but many places I saw that yeah, they're writing yeah, if it's a positive definite, then it's not a positive semi-definite. But something like that, yeah. So yeah, 7th question is given a function f r tends to r, the linear approximation of a function f at the point x plus epsilon d, that is also directly from the definition. Okay, yeah. So yeah, next question, a function is in one variable is said to be convex function if it has a directly
Positive.
Yeah. Okay. So yeah, the option was also yeah, non-negative correlation. Yeah, it is also. What is the relationship between eigenvalue of the Hessian matrix of a twice differentiable convex function? All eigenvalues are positive or non-negative. Both will work.
Non-negative, yeah.
Yeah. A batch of cookies requires 4 cups of flour and a cake requires 7 cups of flour. Okay, what would be the constraint limiting the amount of cookies and cakes that can be made with 50 cups of flour? Okay. So what do you think? Since we need a minimum 4 cup of cookies, so obviously, yeah, we have mentioned as we will represent cookies with a variable. So yeah, it is a 4a and minimum 7 cup for cake. Okay, cake is represented with b variable. So yeah, 7b. So since we have total amount of flour available is 50 cups. So in any cases, 4a plus 7b combination should be less than 50. So yeah, that will be our constant equation. And yeah,
Sir,
like
here the question seems a little confusing because it talks about flowers and then it gives the name A and B to the cookies and the cakes. So, I mean, if the flour is suppose A or something, then we can say 4A plus 7B because we need 4 cups of flour. I mean, I got a bit confused with the question as such.
Okay, just see. I don't think the question is confusing. Yeah, the thing is, see, a batch of cookie requires 4 of flour. Just think, see, that can be made with 50 cup of flour. So we have to made
Flour, the flour quantity is the variable, right, sir?
yeah, flour. Yeah. The thing is here, flour quantity is limited. Okay, we have max 50 cup of flour. Okay,
Yeah.
max flour. Okay, 50 cup. Okay. So this so whatever we will flour we will use, it should be less than 50 cup. Okay.
Yeah.
And we what is the issue here is we have to maximize the amount of cookies and what would be the constant limiting the amount of cookies and cakes. So we have to limit the cookies, number of cookies and number of cakes. So are you able to get the point here?
But sir, how are we getting 4A? That is what I didn't get. I mean, I understand that it should be less than or equal to 50, but how are we getting 4A and 7B?
So the thing is, if
yeah, how do we get the number of cookies and the number of cakes by doing 4A?
See, if I'm saying you have to make 5 cookies, okay, 5 cookies. So how much flour, many cup of flour you will need if you have to make 5 cookies?
For a batch of, I mean, they've not defined what a batch of cookies actually is. I mean, how many cookies does a batch contain?
A batch of cookies requires, see, just
Maybe
repeat.
if the language is changed to like limiting the batch of cookies A and cakes B. So maybe this batch and amount is confusing, right?
Yeah, because the variable here is a flour, and then they take cookies as A and cakes as B, and then they make an equation out of it. So that, I mean, though finally you kind of make out from the options by elimination that this should be the right option, but then the question is a little bit of, I mean, it's a
language
ambiguous.
is
Yeah,
No,
language is a
listen,
little bit
can we let me try to explain. It would be something like this, that if you use like 4 cups of flour, then you get 1 batch of cookies, and like practically you're trying to see by this equation how many batches of cookies you can make and how many cakes you can make out of the given cups of flour, given cups of flour to you. So this is what the equation is. So with this single equation, actually, you will not, I mean, if we see about simultaneous solution of this thing, linear equation, you will not be able to solve. But then using this equation, you are putting the constraint and you will be able to solve once you get other equations. Yeah.
Exactly, whatever you said, that is correct. The thing is, if you see the bigger question, that you will see this question of like operation management. Operation research book. Okay, so there is a book, and where you will see that you have to just a sentence will be written in such a manner, and here is your constraint. Okay, it is like in a factory there are always some constraint. No, like you have limited amount of this. So it is like that only. You have limited amount of floors, and by using that floor you have to make the maximum cookies and maximum cakes. Okay.
Actually, in this question, instead of limiting the amount, it should be limiting the batch of cookies and cakes. So I think that would have cleared the confusion.
Okay,
बट यही लिखा है ना, यही लिखा है ना, constraint limiting the amount of cookies and cakes.
Yeah, she put batch of cookies, batch of cookies and cakes. So that's would have probably cleared. But I am clear about this question. I have no doubt.
Yeah, I also didn't like in the last question also no one corrected on these questions. So yeah.
Yeah, maybe my understanding probably, but yeah, I got a little confused by reading it.
Yeah, in question you will always, the main task will be is see, earlier when I was in the first book when I read about this term in operation research, so there was a question like around 20 line 30 line questions was there, and you have to just the main part was this only, like you have to convert that into the sentences of your constraint. You have to make constraint equation, and you have to make your objective function, and based on that you have to, here you have all the tools, and you are able to solve the bigger questions also, like you are able to solve that this one also, like the a different shape of equation. But in that case when we had this question, we used to convert it in the constraint equation, objective function, and we used to plot this LPP, linear program, based on that but just by simple graph. Okay, we used to solve these questions. Okay, and that was the simple questions also. But what I want to convey is the main task was that only, like you have 20-30 sentences, and based on that sentence you have to identify what would be the correct objective function and what would be the correct constraint equation, like that. So this question, this type of question always okay. Let's move to the next question. 11th question: if objective function which is minimized is fx comma y comma z equals x plus z, and the constraint equation is this one, the point where minimum value occurs will be. Okay, so nothing, just simply we have to do this one. We have to just do this one, del of fx star equals to minus lambda time del of g of x star. Okay, we have to just solve this equation, and second equation is this one, no? G of x y z equals g of x y z equal to 0. If you solve these two equations, you will get the answer in all such questions. Okay, you have to play the game with this equation. Like here you will get, if we have 3 variables, then we will get the equation of 3. You will get 3 equations. Okay, and if we here based on the using these two,
Lambda or only lambda?
anything you will use, just use the same convention. Okay, just
so like for minimizing we will use minus lambda.
Just no, one second.
Is it like
I just okay, just getting a call, just for 1 minute. Okay. In the meantime, you can see the solutions. Okay. Just I think are you able to see that this question? Hello.
Yes, sir.
I think
Yes.
we already able to solve this one. Okay. Second question, 12th question also comes from this one only. Okay, so 13th one, find the points on the surface that are closest to the origin. Okay, so first task will be just to create your objective function. So that is nothing but, let's say your point is x, y, z, and you have to create a distance function from the origin. So this is your distance function, and that will be your objective function, which is you have to minimize that. Okay. And so yeah, again we created this del of f equal to lambda times this one. Okay, and we solve this one. I think are you able to see this one, understand this one or not?
Sir, why do we always take lambda and not minus lambda?
Yeah, I'll discuss that. Just actually, yeah, just give me 10 to, yeah. Actually, delivery boy is at my door. So okay, one second. Let me just tell someone to just collect that parcel. Okay. Hello. Yeah, guys. Yeah. See, yeah, now I can discuss that clearly. Okay. So what will happen is nothing will happen if you will take that lambda as negative or positive. See, just take this question only. Okay. Just the thing is, here you will get you got lambda equals 1. No, in that case you will got lambda equal to -1, and ultimately, but at the end the x, y, z value will be same only. That won't change. Okay. In this question, just see.
So, but there are questions where we are asked to maximize the function. Then how we will decide? We'll go this way only.
The questions are in those questions. If you'll see in this one, here the whatever the points you are getting, that is your critical point. That is not neither your minimum, neither your maximum point. So you have to check. These are. It is something like if you see, it is something like it doesn't depends on lambda. You have some function like that. So after this, these are whatever the point you will get for x, y, z. No, that will be your critical point. It may be from here. Here you are seeing that from where the value are changing. So it is giving you the set of critical points. Okay. Now after putting it in your function, then you will check whether it's a minimum point or your maximum point. Okay. Here see in this question, since constraint question, these are here it is written we get critical points. So these two are critical points. So which one is minimum or which one is maximum? I don't know. When I will put it in the equation, in the function, then only I will get to know whether it's a minimum point or maximum point. Okay.
Okay.
So I'll just show you this one. Okay. So it won't affect your final answer because x, y, z value will be same only. In this question only, let's see here what you are saying that we have to take this one. Del of f x z equals minus lambda times. No, just take it. Okay, here it is taken as a plus lambda. Okay, now I'll take as minus lambda. It is like that. Okay, so f of x, y, z is this one. Okay, so we will do that first. We will differentiate with x, then it will be yeah, x is 1. Okay, y is 0, z is 1. Okay, and for lambda here what we will get is x square. For x square we will get as 2x, y square will get as 2y, z square will get as 2z. Okay, so first equation is your 2x 1 equals minus lambda times 2x. Okay, second equation is your 0 equals minus lambda times 2y. Okay, and third equation is your 1 equals to minus lambda times 2z. I think I should write 2 lambda z, but that's okay. Okay, so here in this question you are seeing that x equals minus 1 by 2 lambda. Okay, z equals also minus 1 by 2 lambda. Okay, it is like that we are getting. But the case is here, actually you are not able to see that changes because see with the lambda values here we are seeing that yeah, lambda value we are getting as 0. Okay, so yeah, actually yeah, in the second question we can see that difference. I would say in the first question, yeah, what I am seeing, what I'm also seeing, you won't see the difference. Okay, I'll just do that in the second question. Here lambda is 1, no, yeah, then we will get as a lambda is -1. Okay, so just do that. This one, the same thing, nothing changes. Just We'll do this. Can we get this one? No, I think yeah, I need to write. We write all these things. Okay. So let's see that. So yeah, first we will x square 2x. Yeah, but if you will ask the lambda value, no, if you will add particular lambda value, then obviously that would be our mistake. If we won't mention that whether you should take lambda plus lambda or minus lambda, and still we are asking about that lambda value, no, that will be, you can argue that yeah, your whatever you said, we will put that both lambda plus and minus value as correct, or yeah, otherwise we will mention yeah whether we should take in this particular question take lambda value as positive or negative. So yeah, but the final answer will be same. Okay, just x square equals 2x, y square equal to y, z square equal to z. Okay, so minus lambda times del of gx star. Okay, so your where is your, yeah, this one is your, okay, for first case you will get as -1. Okay, for second case it will be 2y, and for the third case you will get as a -1. Okay, just solve this one. 2y equals minus lambda times 2y. It is nothing but lambda equals -1. Did you got my point? Lambda equals -1. Okay, so if you will put this one in this one, yeah, again also in this question also we are saying that yeah, x and z is 0. Okay, so you won't see any changes, that will be 0 only. Okay, but yeah, you can I would say you can try in any questions. Okay, you will get the same value. A final x y z value will be same only, just the lambda will be here. If you are getting 1, then in that case you will get as a minus. Okay, nothing extra changes here also you are saying, and yeah, final answer will be same only, just you will get the different lambda value. And the question was, second question was that how to know that minimum or maximum point. That is simply just do this one. Okay, means just check the values of your function on critical points. Okay, so yeah, in the stack this question also, like these are the points which are closest to your origin. Okay, so what is the minimum value of this function? Yeah, the in the portal it is wrongly written as the 0.39. It would be -0.39. Okay, I think many of you had asked it out. This will be the minimum point. Okay, and 0.39 will be your maximum point. Did you got? Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so yeah, I think yeah, we are done with these questions also. So yeah, the minimum value of the function f of xy equals xy square on the circle x square plus y square equal to 1 occurs at which point. So yeah, we when we will solve this question, like we will get this one different value of lambdas, and yeah, by changing that lambda value we will get different set of x and y. So we'll check all the critical points. All of these are just critical points. These are not minimum point, not we can't say it whether it's a minimum point or maximum point. It's a critical point, and we have to check on all the critical points. Okay, in this type of question, mainly mistake you will do, like many times you won't see that the zero part. Okay, it will happen, like in many questions, if you won't solve it thoroughly and in neat manner, you will just miss this zero part. Okay, in many questions. Okay, so in that case it might be the case at that critical point only your function value is 0. Okay, so it's better if you are able to cross check your this kind of function, if you are able to visualize using the graphs, that would be give you the better understanding of the questions, and you can cross check your answers. Obviously in such questions you can't check, but yeah, if there is some question where you can plot the graph, then obviously Mr. Parju, just try to plot, or yeah, just use the GeoGebra. Okay, so yeah, we are done with this chapter. Yeah, all the questions of practice assignment. The minimum value of the function for fx of equals to xy square on the circle occurs at which point. Yeah. So we saw here like at C and D points. Yeah. These 2 points minus we are getting as minus 0.3 and minus 0.3. Here also it should be minus lambda and minus root 2 lambda. Actually, it is not. Yeah, but here it is written correct. Okay, so yeah, I think we are done with this one. Anything else anyone want to share or?
Sir, there are a couple of questions in graded assignment about checking the farthest distance from the farthest point from a certain point. Could you do a problem similar to that? I mean, similar to such a, because I was not able to how to approach. I mean, I could find the points X, Y, Z, but how to find the farthest and the closest point distance I couldn't find.
We will solve such kind of question in your solve this instruction session. That is on Saturday, no? We will solve that question.
Okay, sir. Okay, fine.
Okay.
Sir. Yeah.
Or anything else anyone want to discuss or share? Okay, so bye everyone. Yeah, I think that's all for my side for today's session. We'll meet
Thank
again.
you, sir.
Yeah.
Thank you, sir.
Thank you. Thank you.
Thank
all.
you, sir.
Thank you. Hello, whoever is speaking, your voice is very low. Hello.
Hello.
Sabir? Yeah.
Yeah.
Sabir. Yes, Sabir. Please tell. Sorry, but your voice is very slow. Like we are not able to hear you properly. Is this problem only I am facing, or everyone is not able to hear it?
I can hear you.
Okay, yeah.
Okay. Thank you.
Thank you. Sabit, you are not audible properly. Actually, whenever you say just hello, that we are able to hear you at that point.